Hi everyone, my name is Jyotiranjan Mohanty. Today's fourth question I solving in the top 100 DSA problem. So this question is the remove nth node from end of the list. This one is the linked list problem. We are removing the nth node from the end of the list. So let's begin with that. So here the question said that given the head of a linked list, remove the nth node from the end of the list and return the head. We know that linked list has connected to each other. Each node has address to the other node, and other node has address to the second node. According to that, it will be connected to each other, and after that, it will be pointing to the null, the last node of the linked list, and the first node always pointing to the head. So it will be given to the head. We need to find the nth node from the end of the linked list and return its head. So you need to remove. If there is given by 2, we need to remove the second element from the end of the linked list and return the head. Whatever elements should be present after deleting the node, then we need to return that particular linked list. So here the problem statement, the example said that head 1, 2, 3, 4, 5. They are connected to each other, and at the last of the end we need to delete 4, like 1 and 2. The end of the second position of the linked list, that is 4. We need to delete 4, then I will need to return the other element whatever present in the linked list. So according to that, we need to delete the element. So we know that linked list has not a kind of array, cannot travel, cannot find the length of the linked list in like simple using the inbuilt method like array dot length. We cannot find according to that. We need to find the length or a kind of thing will be we will do that. So we don't know what is the length of the linked list. We have the two things as head, that is the whole linked list, and n, that is the n is the end of the node of the linked list. So here is the first base case I need to written over here. So if my head is already pointing to null, like is my head is already pointing to null, like if a head is already has not a head is not present, like it is already null, then we need to simple return null, because it's like head, it's simple head or null, we need to return, because it's not present any element, we cannot delete any more nth node of the end of the linked list. So here is the first case. So I will be giving the two outputs. The first one, I will first of all giving the simple method. Then I will giving the two pointer method as well. It will be very effectively solve the problem also. So first of all, we need to solve the problem in according to the problem. How to say? The first, I think, in my mind, I can traverse the each of the element of the linked list, so I can find the length of the linked list. After finding the length, so I can remove the, then if I finding the length of the linked list, then I have the 5 element inside the linked list. I need to delete the second element at the end. So I can delete the after finding the length of the linked list, so I can I can find the which node I need to delete. So 5 minus 2, like 3. After third element, I need to delete the fourth element. Like if it is here is 1, so here 1 means the last node. So the length of the linked list is 2. If I 2 minus 1, after 1, that is one element I need to delete. So according to that, we can delete. Also, you can apply the reverse of the linked list method as well. If I need to reverse the linked list, and after reversing, and you need to traverse one by one, and if the length would be equal to the 2, then you can delete the particular node also. But reversing the linked list is very difficult. Like it will be very messy. The code will be very messy. You cannot if you reverse the code to every time, if you reverse the code, if you reverse the linked list, then we need to delete that node, then we need to again reverse. But because you did not return the reverse linked list, we need to again reverse the actual what linked list is present before reversing. So I can tell the simple method. So first of all, I need to find, like, I take a count variable. So here it will be first of all 0. I'll take my file condition. Inside while I can take another one variable also, because I need not to want my head will be like pointing to other variables. So I have the current. If current is pointing to now head, if my current is true, like it is value should be not pointing to null, then I need to traverse like my current equal to current dot next. If I traverse, then that time I need to find the count of the like length of the linked list. I will be increasing my count. After that, I can finding the length of the linked list of the count. Inside the count, the link other inside the count, my all the like length of the linked list will be there. So one more condition, now I have the count. Okay, fine. If count like so let like I need to find the which linked list I need to delete. So I need to minus that nth node, n node I can rename as n node equal to count minus n. So here one more condition also there. If n is already pointing to 0, n equal to 0, then I need to return head. So here is nothing to be delayed because it's pointing to 0. Else if n node is equal to that count variable. If it is equal to count, then I need to return head dot next. It means that it is pointing to the count. Like if my n is pointing to 5, like if my like length of the linked list is 5, and my n also pointing to 5, that like n node and the count n node equal to 0. I think it should be 0. If it's 0, like after my count and n will be removed like minus, then it will should be pointing to 0 because the length of the linked list is 5 and n also 5. That should be it pointing to 0. 0 means it should be pointing to 5. N is pointing to 5 means there is 5 element. I need to remove the element should be from the end of the linked list, 5 element like 1, 2, 3, 4, 5. The first one. So if I delete the first one, then I need to return head dot next. So that it will be like my base cases. It will be take care of all this thing. So now I'm writing the case like traversing the linked list to delete the element inside the linked list. So I need to take another current variable, current 2 equal to, it should be pointing to head also. If my current 2 is not null, I need to traverse. So I need to take another variable like number. It should be for pointing to every time. It should be starting from 1 because I am starting from first linked list. So it should from 1. So every time if my number equal to, so I need to run the loop. I need to make it dynamic also. I need to run the loop. If my number should be less than my n node. If it is less than, then I need to break the loop now because I am right now in this position. Which node to be deleted? I am at the second previous element. So I need to, if I am at the second previous element, so I can go to directly this element. I need to remove this element. So that time I need to traverse current 2 equal to current 2 dot next. So after here I am writing, then here I am writing current 2 dot next equal to current 2 dot next. So I need to return head because head is pointing to all this thing. So here, if the loop will be break, it should be pointing to previous element of the node. So if it is pointing to the previous element, then it will be not pointing to here. it will be pointing to the next element should be current dot next, like it will be pointing to this element. If I run, let's see what happening. I think I'm getting some error. Current to equal to current to dot next. It is not correct. N node number, let number equal to one. Number is less than. Okay, I need to keep increment the number also. Number plus plus. Okay, fine. Uh, if number plus plus, okay, fine. Now, because the number should be again like plus plus, it will be go one, it will go two, it will be go three. If number will be pointing to the like n node, like the three of the element, like previous element. Now I need to break the loop. I need to pointing to the remove the element and pointing to the next element. Now it will be giving the answer. If I go to submit, I think it will be submitted. Yeah, it's accepted. So I am tell you the second approach also. This one the first approach. It may make me lengthy also. The second approach I can make the two pointer method also. If I am using two pointer method, I am taking one answer like answer equal to. I am taking the first equal to head. Let slow equal to head. So both are pointing to head. So first of all, I need to run a loop for let I equal to 0, I less than till n I return a loop. Till now, I need to traverse the my first element, my first equal to first dot next. So I'll be telling what will be happening. So first of all, I need to my base cases will be here. My this base case is always true because my head is pointing to null. Then I return simple head like null. So here what I am done. I am going to till n variable like whatever the n. If n is two, then it will be go to second number of node. If it is go to second number of node, then we need to start our fast and slow. Our fast and fast dot next is not pointing to null. Then I need to traverse fast equal to fast dot next slow equal to slow dot next. So here I am taking care of the all these things like slow pointer from the initially stage. My fast pointer will be from the fast pointer will be pointing to this. My slow pointer will be pointing to this. But after then I am writing the loop for till n. I need to traverse the fast pointer. So my fast pointer will be go to if there is element is two, then my fast pointer will be go the second element, the two. My fast pointer now here, my slow pointer will be here. Now I am traversing the fast and slow pointer, both are equally. Now every step, my fast pointer will be go here, my second like slow pointer will be go here, and till now it will be traverse because fast pointer will be always keep updating of the till nth node because it is getting like it will be nth starting from nth node. That's why it should be fast. It should be after you keep going, it should be fast, like pointing to null. Because slow will be in the previous side. Because slow will be at and slow and fast, they have the distance between nth node. So slow will be in the behind of the fast, and fast will be keep forwarding, and slow also keep forwarding according to the fast. And the distance between are same, that nth node. Because of the nth node, this distance, that will be they will be pointing to if the slow will be pointing to this, then fast will be pointing to null. Then we need to break the loop because fast and fast dot next will be pointing to null, and my slow will be pointing to the whatever node we need to delete, that will be pointing to the previous element. Because I am writing the fast pointer from the starting position, it will be go to the first nth node of the node. So if my slow will be pointing to the previous element of the what should be delete, then slow dot next is equal to slow dot next dot next. So if I return head, I think I might be getting my answer. So if I get to go to run, mm, I think slow dot next equal to slow dot next dot next. I think a slow dot next reading next. Slow equal to slow dot next. I think I'm gonna have some missing fast dot next. One more condition is there. If fast, then return head dot next also. I'm telling you why I'm writing this also. Yeah, because of this it's true. Okay, fine. So here the fast will be also like giving that like it will be check that best cases also. If fast is already pointing to null, then if it fast is already pointing to the null, then we need to like return the head dot next, because if there is a five element and our n also five, then fast will be go till five element, and it will be go to the like pointing to the null. Because it should be pointing to the null, then we need to remove the fifth element from the end of the list. That should be the first one. So we need to simply return head dot next. So that slow and fast pointer have that much of distance from the initial stage to the final stage, like fifth element. So this loop will be not running for because of this condition, because it should be pointing to the first of the position, like fifth element, one, two, three, four, five, then it should be not go. If I go to some bit, I think it will be getting some bit accepted also. Yeah, it is accepted. So fine. So I'm telling things like here I'm showing how it's working. Yeah, fine. Here, my fast will be my fast up or my slow will be pointing to here. Then my fast also pointing to here, because n is two, because I need to delete second element from the end. So I am always keep distance between the slow and fast. These two elements, because if distance is between two element, if I keep forwarding in the like linked list, then if my fast will be pointing to null, then slow will be pointing to that particular element or previous element for the what need to be deleted, because second element. If I go to the my fast pointer to the nth node, like if my fast pointer will be one, then second two, this one. Now my fast will be pointing to this one. So if my fast will be pointing to this one, because I need to delete the second node. So if I have my fast pointing to this one, fast pointer will be one here, zero, then one. Now here. So okay, from zero one it will be here. So now I am keep updating my fast and slow, both are equally. My slow will be go here, my fast will be go here. Then my fast slow will be go here, my fast will be go here. I think zero one. Okay, fine. Zero one. No, fast will be pointing to here, because the distance between slow and fast two. So that's why it should be pointing to this element. So now I can say now my pointer will be here. The my fast pointer will be here. If my slow pointer will be here, my fast pointer will be here. If my slow pointer will be here, then my fast pointer will be here. If my fast pointer will be here, my fast dot next will be null. If my fast will be null or my fast dot next will be null, then I need to break the loop and like out of the loop. If my go out of the loop, then my previous point will be pointing to the first node will be deleted. It should be pointing to that particular element. So then I need to delete that element. I need to delete this element. So I am always pointing to this element. If there is a sixth number of like thing, then if my I need to delete the thing like second and third element. if my fast pointer will be pointing to here, and if there is a second node need to be deleted, this one, then 3 will be pointing to slow will be pointing to 4. So in this way, it will be deleting the element inside the linked list. And I'm telling that my fast pointer, like always, my fast pointer and slow pointer, like fast of all, my fast pointer will be slow pointer to pointing to this. But after that, my fast pointer will be go here and slow pointer will be here, because I'm running fast loop, because the fast pointer and slow pointer distance between them are whatever the n should be present. If my fast will be go, if my slow and fast both are equally go, then it will be fast will be pointing to the fastly to the null. If my fast pointer will already pointing to the null, then the slow will be here. The whatever element should be deleted to be, it should be pointing to the previous element. If I am finding the previous element of the linked list, what should be deleted, then I need to directly like pointing to this element. I am removing also this element. So in this way, I can already tell about two approaches. First one, the simple one, like to like finding the length and like remove the nth node of the like length of the linked list. Then according to that, we can traverse the particular element in the linked list, and we can delete that particular element also. And also we can using the 2 point method, and equally we can like go further and keep distance between the fast and slow also. According to that, we can like remove the particular element as well. So third one approach is to find reverse the linked list and remove the particular element, then again reverse the linked list. It should be getting complicated sometime, because reverse linked list is need to reverse every time. Like you need to reverse the first linked list and you need to reverse the second linked list also. So that way we can delete the linked list. So that's for today for the reversing the remove the n node of the linked list from the end. That's for today. So I think I hope you will be getting some idea about how to solve this problem. I am giving I gave that two approach for the problem. And third one also I'm telling that reversing the linked list also. It is not good idea to every time reversing the linked list and finding the delete the node and again reverse this thing. So you can simply traverse the linked list and try to finding the length, and we can getting the answer about how according to length we can traverse the particular node to be deleted. And two more pointer method is very good method to delete the linked list. So I hope you will be getting some idea about this thing. So thanks for like watching this video. If you are getting some idea, then please comment out here also. So I am in the upcoming video, I am telling about like how to reverse the linked list, and in the reverse linked list, we can how to add some element and keep summing them. So I will be tell about this thing also. So that's for today. Thank you.